Alright, I'm going to get started here. It says I'm dropping frames today, so new problem. Uh, if you experience that, let me know if things aren't coming. Uh, but my connection seems fine. It might be on YouTube's end that I'm dropping frames. Maybe it'll clear up. I don't know. I'm just going to go with it. Again, if you have questions, don't understand something, email me. I can get you something that way. First off, I'm going to ask if there are any questions from the test. I returned the test yesterday to you and asked you to rework out some of the problems that you missed and to resubmit to me. I would like that resubmitted by the end of the week if you can. But if there are any questions on, hey, why you missed something, now would be a great time to ask. Big thing was naming, so if you want to look up in your notes the different names for things. Another big thing was combining like terms, which was shocking because we've been doing that all year. But you know, it happens. If there are no questions on the test right now, I'm going to start solving quadratics with you, which is a fairly complicated process. But there are easier ways to do it. We're just going to do it kind of the hard way today. I'll give you another minute if you're looking at that test to see if you have any questions on it. Also, if you don't have your notes up, you should probably get your notes out and follow along with the notebooks. When is all the science due? I'm trying to get science chapter 6 on forces due by the end of the month. That might be asking a bit much for you. I believe I just posted your assignment sheet and I just posted your quizzes. But I am going to be flexible on that date because of all the distance learning, weird schedules, things are happening. And if the quarantine starts to loosen up, then we're also going to have some more parents starting to go back to work. And your schedules are going to get screwed up then too, because I don't know how you get supervised when all that happens. So just be flexible with it, but I'm projecting the end of the month. But if you need more time, just let me know. I'll give you more time. And if you have questions on science, you can email about those too, or you can ask at the end of math classes. Forces might get a bit more complicated because it is going to get a little bit more mathy. There is still one more assignment I have to give you on that chapter before you can complete anything, or complete all of it. Number 15 on the test. Yeah, let me, I got to bring up my test real quick here and figure out what it is going on. Number 15. I don't know what it is off the top of my head. I don't think this likes, no, this does not like exponents. Okay, so let's look at 15. 15 says 16x to the third plus 12x squared minus 8x minus 6. And it's asking you to factor this. First thing you should realize is that there are 4 terms, so you have to factor by grouping, because I didn't show you any other way to do it. Next thing you need to notice is that you can actually factor out a 2 out of all of this. So we're going to go ahead and factor out that 2 first. So we're going to divide each of these terms by 2 and get a 2 out in front. So I'm going to put our answer up here. We know it's going to have a 2 out in front. And it's going to be multiplied by your other factors. That's going to leave you with 16 divided by 2 gives you 8x cubed plus 12 divided by q gives you 6x squared. Negative 8 divided by 2 gives you negative 4x, and negative 6 divided by 2 gives you negative 3. So you still have your different terms here, but it is a little simpler now because we factored out that 2. I saw a lot of people not factor out that 2, so that might be your mistake right there. Again, I don't have your test in front of me, I just have a blank copy of it. Once you get there, you got to factor by grouping. So you're going to group these two together and group these two together and see what you can factor out of each of them. This one here, you can factor out a 2x squared. So we're going to factor out a 2x squared from all of that, and we're going to be left with 8x cubed divided by 2x squared is going to give you 4x. And over here, you can factor out a 2x squared as well. So 6x squared divided by that is going to give you a positive 3. Over here, it's kind of hidden, but you can factor something out, and that is a negative 1. You can factor out that negative 1. In doing so, you're going to get negative 1, and it's just going to change your signs, 4x plus 3. And then together, you factor out the 4x plus 3. So a little tricky with the 2 at the front and a little tricky with the negative 1 here, but you can factor out the 4x plus 3, and what's left is a 2x squared minus 1. And again, you're going to, don't forget about the 2 that you factored out at the beginning, and just to make life easier, you tend to put higher degree terms first. I did not take off if you didn't do that, but it is a better idea. And there's your answer for that. So you get that. So again, mistakes were probably made with the factoring out of the 2, and this negative 1 was hard to pick up on. Are there any other questions? On the test? If not, we're going to get into solving quadratics today. So we're going to take everything we did last chapter and actually solve for your x term. So if we have only one unknown variable, can we actually solve it? And we can. We just got to have a little background information still and go from there. So first off, this is our objective today, is to solve quadratic equations. Now I'm going to remind you not to forget things from last chapter, because you're going to use all of that in order to do this. We're going to do this a little differently first. We're going to start by solving it by graphing, which we did last week a little bit. And then we're going to solve by using square root properties, which we did yesterday. And then later this week, we're going to actually solve it by factoring and doing it that way. So it's going to be a lot easier to do it by factoring because it's going to fit more cases and it'll be easier to do than graphing things. And the square root's not going to work for everything. Once you do that, we also have a quadratic equation that you can just plug into, and it will solve these for you if you can work the equation. So there are multiple ways to solve these things. We're going to go through each of them, starting probably with the one that is the most work, and then going to the one that is the least amount of work. So in the end, you'll have a repertoire of tools to approach them. And it's going to depend on your context on which one is going to be easier to do which way. So one way is not necessarily harder than the other. It just depends on what numbers you're given. If you're given really ugly numbers to work with, then graphing it probably isn't the way you want to do it. But we are going to solve by graphing. So let's recall what a quadratic equation is. And those are anything in the form of ax squared plus bx plus c. And in this case, they are going to actually equal something. So we're going to say it equals 0, which we're going to know as a constant eventually. And you're going to set things up so it equals 0 and then solve from there. And we're also going to remind you that a cannot equal 0 here, because if a equals 0, then this term cancels out to 0 and you don't have it anymore. And then it's just a linear equation. It's not a quadratic. So if a is 0, it's not a quadratic equation. So this here is the form we're looking at. That shouldn't be new to you. Again, this is called your standard form. So this is what we call standard form. The other thing you need to know, that we are, to solve the quadratic equation, this means solve for x. So that's what we're doing today. We're solving for x. My fingers are going to let me write today. We're going to solve for x today. In doing so, just looking at this, there are a few things you should be able to recognize. And the first thing is that x can have one solution. Right? If x was 0 here, then c would also be 0. It would only have one solution. So x can have one solution here. The other thing you need to realize is that x can have two solutions. I should have the word have in there. X can have two solutions, and that's going to come in play because of this term right here. Whenever you have something to the second power, you need to solve for it. You do the inverse, which is taking the square root. And we talked yesterday that when you take the square root of a number, for example, the square root of 25, it has two answers. It has a positive and a negative 5. So every time you take the square root of something, you have two answers. And therefore, this is possible to have two solutions. The only time it won't is if this x term here, whatever this term is, works out to be like the square root of 0 here, which is only going to have one solution to it. It's not going to have two solutions. You can't have positive and negative 0. The other thing you should realize, I'll leave that up there. So this here will give you, I'll put it in this order. So for example, if the square root is 0, you're going to have one solution. For example, if the square root is 25, you're going to have two solutions. Right, plus or minus 5. The other thing you need to realize is that x can have no real solutions. And that's going to be when this term over here, you find that you're going to take the square root of a negative number. In that case, well, we'll do -1 because that equals an imaginary number, which is I. You can't do it. In our class, we're not going to get into imaginary numbers, so you don't need to know that stuff yet. Algebra 2, you will. But for you, you're going to be writing no real solution. And the fact that there is not a real number that works for it. And that makes sense when you go to graph as well. So let's look at this graphing-wise. Solving quadratic equations. We want to solve for x. In other words, when we think of graphing, we want this to be, where does the graph cross the x-axis? those will be your solutions. When we solve for x, when we want y to be 0, what is x? Right? Remember your form. Ax squared plus bx plus c equals 0, right? When y is 0, what is x? So that's our x-intercept. So in other words, this is your x-intercept. So I want to find x-intercepts. We also already know that quadratics in this form parabolas. So we can have one solution. You can have one solution to this, and that's your graph is going to be in the form of, hey, that vertex has to be on the x-axis. Graphs like this are going to have one solution. There is only one place for that graph to cross the x-axis. It could have two solutions. In that case, your graph is going to look like this. Right, so this graph here has a solution here, has a solution here. This graph here will have a solution here and have a solution here. That's the only solution, that's the only solution. Right? Or it could have no real solutions. And that's the case where it doesn't cross the x-axis. And you can easily have graphs like that. There's one. There's one. These graphs don't touch the x-axis, so they're not going to have any real number solutions. So keep in mind when they have no solutions, make sure you write the word real there because they actually do have solutions. They're just imaginary. But these are your options. You can either have one solution, two solutions, or no real solutions. And this is why we start with graphing, because again, what are we actually looking for here? We're looking for the x value. We're looking for where this graph is going to cross your x-axis. Or we're looking for the x-intercepts. Again, there could be two. It's not going to be three because these graphs don't do that. When you get into cubic functions, it can be three, but you're not going to get into that. In fact, cubic functions will always have at least one real solution. They could have some imaginary solutions and some real solutions, but it will always have at least one real solution with that. So the first way to solve these things is just by graphing. So let's graph some and find the actual solution. And this will be a good reminder of how to graph from last week. I didn't have you submit any graphing because I didn't want to sit there and decipher your graphs, but this week you can submit things because there'll be actual answers. I'm looking for your x-intercepts. So this is solve quadratics by graphing. And I'm going to quickly find some graph paper here. Don't remember which one I was using last week. Well, there's a graph for us. Hopefully we don't need more than that. No, we shouldn't. So let's solve by graphing, and we're going to graph some simple ones. So remember we have, what is our form? Our form is a squared plus, or ax to the second plus bx plus c. Remember that is our form. So we have an a value, a b value, and a c value. And again, if you're following along with the PowerPoint, I'm going to do the examples that are in there first. So we have Example 1 is going to be x squared minus 4 equals 0. So just looking at it, you know that you have an a value of 1 because the coefficient in front of x squared is 1. You know that you have a b value of 0 because we don't have a b term. And you know that you have a c value of negative, what is that, 4. Right? So the first thing you need to do is find your axis of symmetry. Symmetry, however you spell that. Find your axis of symmetry, and remember that is going to be x equals negative b over 2a. And in this case, it's going to be 0 because b is 0. So here, when you plug everything in, you get negative 0, which is just 0, over 2 times a, which 0 is your numerator, so that's going to equal 0. So x is going to equal 0, so your line of symmetry, if I were to put it on there, is going to be your y-axis, where x equals 0. So it is going to be there. Once you figure that out, you're going to find your vertex. Vertex is at, your x value has to be 0, which tells you right away that 0 is going to be one of your solutions to this. Is it? No, because that won't equal 0. I don't know. Your x value is going to be 0. It is going to be a solution because it's going to cross over, I guess. X value is 0. Oh, I'm sorry, no, that's the line of symmetry is at 0. Your vertex is going to be at 0, and then when we plug in 0 for it, you're going to get negative 4. So this here is not a solution. We want y to be 0 for solutions. Sorry. So negative 4 is where our dot is. So that's right here, which does not cross the x-axis. Excuse me for my confusion a bit. Right. That's it. And then you want your y-intercept, which is what this vertex is going to be. Your y-intercept is also going to be your vertex. So, I'm sorry, to get the negative 4, you plug in 0 squared minus 4 equals 0. Whatever that is. This is 0, so whatever that equals. We're graphing it. Once we do that, we are going to get y-intercept we already have, which is negative 4. And then we need some more points because we just simply don't have enough information to graph this yet. Our y-intercept didn't give us a point because that's the same as our vertex, so we just gotta find more points. So we're just gonna plug in our xy table, and let's plug in 1. 1 squared minus 4 is, 1 minus 4 is negative 3. 1 and negative 3. So we are going up here, which again makes sense because a is positive, so it should be going up and have a min. If you recall that from last week. Let's get the reflection of that, which would be over here. And let's get maybe a 2 in there. 2 squared is 4 minus 4 is 0. So 2 and 0. That gives you a solution right there, and its reflection is over here. So you can see how our graph is forming like this. Our graph is forming like this. And our solutions, so the actual answers to this, solutions is x equals 2 and x equals negative 2. Because they're these points right here. They're your x-intercepts. So we went ahead and found our solutions to it. And you can check that out. You can plug them in to solve. So 2 squared minus 4 equals 0, and negative 2 squared minus 4 equals 0. So those work out. They are good solutions. That's what we're looking for. Okay. We are going to solve another one together, but I'm going to leave this one on there, and I'm going to solve it in a different color here. I'm going to graph it on the same graph, just so you can see differences, because I think I picked one with solutions. Yeah, I picked one with 2 solutions, one with 1 solution, and one with 0 solutions, so you can see them all. So the next one is x squared equals 0. Again, we have an a term, which is 1, a b term, which is 0, and a c term, which is 0. Axis of symmetry is x equals negative b over 2a. That is 0 over 2, or 2 times 1, which again is 0. So your axis of symmetry is in the same place. It's on that y-axis. Your vertex is x equals 0. So when x equals 0, 0 squared equals 0, y is going to equal 0. So your vertex is at 0, 0, which is your x-axis. So your vertex is right here. Solution-wise, you could probably stop there. Hey, you know the vertex is there. You know this is opening upwards. You know it's going to have a min, and that min is your vertex because you can't have anything smaller than that, than your vertex. So it's only going to cross the x-axis once, but let's go ahead and graph some other points. Our y-intercept is the same as our vertex, so that doesn't help us, but we can put in some other points there. So let's make an xy table and plug some things in. What happens when x is 1 and x is 2? 1 squared gives you 1. So when x is 1, that's 1, and that's going to be reflected over your axis of symmetry, so you get that point, and 2 squared is 4. And that gets reflected over your axis of symmetry as well. So this one here looks like this. And you can see how this one here only has 1 solution right there. Again, not too bad on graphing these ones because there's just not a lot to the equation. I don't want to take all of it. Let's do our last example in red here. So in this one, we're going to do x squared plus 4 equals 0. So we had x squared minus 4, which was the black. We had just plain old x squared, which was the blue. And this is x squared plus 4. Just knowing how graphs are working, you should see this is slowly moving up as I increase my c value. So this one here should be around the 4 and going upwards. But just to make sure, we'll plug everything in. Oh, I'm sorry, c is actually 4 here. Right, so your axis of symmetry is x equals negative b over 2a. In this case, it's still going to be 0. Your vertex is going to be when x equals 0, what is y? 0 squared gives you 0, plus 4 gives you 4. So your vertex is at 0, 4, which is what we're kind of predicting anyways. And again, this is positive, so it's opening upwards, and you have a min. So this is the smallest number. So right away you can tell that, hey, this is opening upwards. It's not going to cross your x-axis. So in this case, there's going to be no real solutions. But we can just plug in a couple numbers to double check. Let's find out what x equals at 1 and 2. At 1, you have 1 squared plus 4 equals 5. So at 1, you're at 5. And then the symmetry is going to be there. And at 2, you get 2 squared plus 4 equals 8. So at 2, you're at 8, you're over here, and the symmetry puts you there. And you can see this graph is not going to cross your y-axis, or your x-axis, sorry. So here, your solution is going to be no real solutions. You will get into imaginary numbers with the quadratic formula a bit. You might, I don't think you're, depends on what kind of calculator you're using, if it's going to actually give you answers to that or not. But if you ever find yourself doing the square root of a negative number, it's going to be no real solution. So that's graphing them. Just kind of graph them and find out where they cross at the x-axis. The other way I'd like to go over on how to solve these is using algebra. And again, these are going to be for fairly simple ones with not a lot going on. However, you can do it with all of them. It's just going to be more complicated for you, and there's just easier ways to do it. But let's solve by solve. How do you spell solve? Solve by, I guess I'm calling it square roots. So using what you know from yesterday, how to solve these. With that in place, these are going to be when you have kind of perfect squares to deal with. So it might be easier one way versus the other, but you are welcome to leave things in the form of a radical as well, which is a better answer. So writing the square root of 2 is a better answer than writing like 1.42, whatever it is. This is the preferred answer, just leave it under the radical. And there are ways to simplify that, like there are ways to simplify fractions, but we'll get into that later. So let's solve one using square roots. So our example would be t squared minus 25 equals 0. Let's find out what t equals. So all that you're going to do is your algebra here, which isn't going to be too difficult for a lot of these. When you have b terms, you're going to struggle with doing it this way. It's not nice and it's not pretty. So when you have a b term, so when you have ax squared plus b, I don't know why I read it 2 for that, bx plus c, when you have this term, it's going to make things a lot more complicated because you can't combine these to make one x. So it's going to be a little difficult to do. But here, and for today's practice, you're not going to have b terms. So here we're just going to solve for 0, or I'm sorry, solve for t. And do your algebra. You can do order of operations in reverse. So again, you're subtracting here. So let's add 25 to both sides. And that's going to leave you with t squared equals 25. And in order to get rid of that square, you have to take the square root of this, because those will cancel. Remember, a squared, the square root of a squared is a. This cancels with this. So the square root of t squared is going to be t. This side's going to cancel out. And you're going to take the square root of this side, and that's going to equal plus or minus 5. So here you do have two solutions. Plus or minus 5 are your solutions. Again, these aren't going to be too difficult if you don't have a b term and your square root is nice. But it does have two solutions here, positive 5 and negative 5. And you can check that, because negative 5 squared minus 25 equals 0. Negative 5 squared is 25. 25 minus 25 is 0. And 5 squared minus 25 equals 0. 5 squared is 25. Minus 25 is 0. So this does work out as one example. And it's not too difficult to do it with square roots when they do work out well. Next one we have is 3n squared plus 12 equals 12. Again, you're just doing your algebra. We're going to subtract 12 from this side, subtract 12 from that side, and you get 3n squared equals 0. This actually worked out nice because of that 0. I don't know if that was a typo or not, but it worked out nice because of the 0. Or, oh wait, no, I did this because it only has one solution. That's why. And here you're going to divide by 3 then. Divide by 3. And you're going to get n squared equals 0. These 3's will cancel. Then you take the square root here, take the square root here, and you get n equals 0. And in this case, there is no plus or minus because there's no positive 0 or negative 0. It's just 0. So in that case, you only have one solution to it. The other one that you need to be aware of is things that aren't going to work out nicely. Is 2g squared plus 32 equals 0. In this case, again, do your algebra, get g squared by itself. So here we got minus 32 minus 32. Over here we have 2g squared equals negative 32. Divide that by 2, divide this by 2, this will cancel. I'm sorry, this cancels. Leaves you a g squared equals 32 divided by 2 is negative 16. Then you take the square root of that and take the square root of that. Here you should be seeing that, hey, I'm taking the square root of a negative number, which means you have no real solutions. You cannot do the square root of a negative number unless you make it imaginary. So you will have no solutions here. With that, your practice, your assignment is actually 2 days long, and I might give you more time. I don't have that up anymore. I might pull that up. I'm looking at page 531, 1 through 21. I did split it up into two, I think. I think I asked you to do odds one day and evens one day. Yeah, so I asked you to do the odds today, and tomorrow you're going to do 1 through 21 even. And I think that's already unlocked. So it's not going to be a new kind of like notes, it's just going to be more practice. I just split it up. Some of them you do have to graph, so it does take some time, so I gave you a couple days to do it. So you can work on both of those today, but I want them due by the end of the week. I mean, just to give you time to do things. But this was technically for today, and this is tomorrow. They are both unlocked. I will live stream again tomorrow if you guys have questions on things, and you need to have me review something on it, but we're not going to have any more notes on it until what is it, Friday probably, when I show you how to do it with factoring, which is probably my favorite way to do it. But again, even when factoring happens, some of these you can't factor. It's not going to be nice to factor them. So it depends on the situation on which method you're going to do to solve this, but we're just going to be practicing today. So if there are no other questions, class is technically over. And this goes for science too. If you have any questions on science, please make sure you're asking. Forces can be a little complicated. If you're working on the quizzes and you're not quite sure how to do something, let me know. I can give you a little further advice. Quizzes, I would like you to get them to me by Friday, if possible. And if you have questions on it, you're not sure why you missed something, you can ask. I am going to update the grade on it because a lot of you made some pretty stupid mistakes, to be honest with you. What's that? If you have further questions, send me an email. But our time is up for today. Practice this. We'll practice it tomorrow, and we'll do a couple more tomorrow if you need it. Questions on your test are fair game. Ask questions about science. Fair game. Ask anything you need help with. Let me know if you feel like you are completely overwhelmed with things. Let me know that too. I can tone things down a bit. I'm not exactly sure if the pacing of this is working for everybody. So just keep me informed if you have any questions about things. With that, it looks like a lot of you are turning in or resolving issues on your test. Thanks. Remember, combined like terms, factor things out. Look up the names of things in the book. I'm surprised people missed that one. But look them up. All right, I'm ending it. I will talk with you tomorrow.